Okay, here's a question that's going to blow your mind. Which one of these maps is telling the truth about our world? This one, where Greenland looks almost as big as Africa? This one, where Africa looks massive but the shapes feel off? Or maybe this weird broken up looking one? Here's the plot twist. They're all lying to you. Every single map you've ever looked at in your entire life has been feeding you lies. And today I'm going to show you exactly how and why. If you're taking AP Human Geography, you've probably realized that this class is way more than just memorizing capitals and countries. We're talking about understanding how humans interact with space. And maps are the secret weapon for cracking that code. But here's what your textbook probably didn't tell you up front. Every map is basically a magician performing tricks right in front of your eyes. And by the end of this video, you're going to know all the tricks. I'm going to break down everything you need to know about Topic 1.1, Introduction to Maps, in a way that actually makes sense. We'll cover the two main types of maps, the spatial patterns they show us, and why every single projection is playing games with your brain. Let's start with the big picture. The science of map making is called cartography. Maps exist to show us spatial patterns, basically how stuff is arranged across the Earth's surface and why that arrangement matters. Think about it like this. Imagine you're looking at where all the biggest cities in the US are located. A geographer gets excited about questions like, why did New York and Los Angeles develop on opposite coasts? Why does Texas have 5 cities with over 1 million people, while Montana's largest city has only 120,000? These aren't random. There are patterns, and maps help us see them. Now, there are 4 key spatial patterns that maps love to show off. First up, absolute versus relative distance. Absolute distance is the measurable GPS-style distance. Like, Denver to Chicago is 920 miles. Done. Simple. But relative distance, that's where it gets interesting. This measures the social, cultural, or economic distance between places. Second, absolute versus relative direction. Absolute direction equals your basic north, south, east, west compass directions. Relative direction equals turn left at the Starbucks, then right after the weird statue. Guess which one actually helps you navigate to your second period class? Knowing it's northeast of the main office? Or knowing it's 2 doors past the library? Exactly. Third, clustering and dispersal. Some things like to hang out together. That's clustered. Think apartment buildings in Manhattan. Other things prefer their space. That's dispersed, like farms in Iowa, where your nearest neighbor might be a mile away. Fourth, elevation. How high or low things are compared to sea level. Mountains, high, Death Valley, not so much. Now here's where maps split into 2 major personalities. Reference maps, the practical ones. These are your get stuff done maps. Need to find the nearest Sonic? Reference map. Want to see state boundaries? Political reference map. Planning a hiking route? Topographic reference map. Reference maps can show you locations, boundaries, roads, the concrete stuff you can actually visit. Thematic maps, on the other hand, are the storytellers. These maps have something to say. They're not just showing you where things are, they're showing you patterns, data, and relationships that tell a story about our world. Let me show you the 5 thematic maps that are going to pop up everywhere in this course. First, choropleth maps. These are color-coded. Different colors equal different data values. Darker usually means more, lighter means less. Second, dot distribution maps. Every dot equals a data point in its actual location. These are super precise about where things are happening. Back in the 1850s, a guy named John Snow used a dot distribution map to figure out that cholera was spreading through contaminated water. Not bad air like everyone thought. Maps literally saved lives by showing the pattern. Third, graduated symbol maps. Bigger symbols equal more of whatever we're measuring. Fourth, cartograms. These are the shapeshifters. They distort the actual size of places to show data. Fifth, isoline maps. These connect points with equal values using lines. You see these all the time in weather maps. Those swirly lines connecting areas with the same temperature, for instance. Okay, remember those lying maps from the beginning? Here's where we blow this whole thing wide open. The Earth is a sphere, maps are flat, and therein lies our problem. Imagine trying to flatten out an orange peel perfectly. It's impossible without stretching, cutting, or distorting something. That's exactly what happens when we try to show a round Earth on flat maps. This brings us to the essential knowledge that the College Board wants you to know. All maps are selective in information. Map projections inevitably distort spatial relationships in shape, area, distance, and direction. Let me show you the major players. First up, the Mercator projection, the classic liar. This is probably the map you grew up with. It's fantastic for navigation because directions are accurate, but it makes places near the poles look absolutely massive. Notice how Greenland looks bigger than Africa? In reality, Africa is about 14 times larger than Greenland. Talk about geographic smoke and mirrors. Peter's projection, the size truth teller. This one shows countries at their true relative sizes, which makes Africa look properly massive. But everything looks stretched and weird, because to get the sizes right, the shapes had to suffer. The Robinson projection is what I call the compromise, because it tries to balance everything out. It spreads distortion around so no one area looks too crazy, which is why modern geographers often prefer it. This is the real crazy one, the Goode Homolosine projection. It breaks up the oceans to keep land masses accurate in both size and shape. It looks quite strange, but at least it's honest about what it's doing. Last on our list is the polar projection. It views the world from the North or South Pole. Great for showing Arctic relationships, but everything gets more distorted as you move away from the center. Next, let's talk about scale. This trips up a lot of students. There are actually two different meanings of scale in geography. Map scale tells you how distance on the map relates to distance in real life. You might see it as 1 to 100,000 or as a little bar showing miles. This second type of scale you'll need to know is called scale of analysis. This is about how zoomed in or out your view is. Large scale equals zoomed in. Lots of detail. An example of large scale would be a small area, like a neighborhood map. Small scale, on the other hand, equals zoomed out. Less detail. So we're talking about a big area, like a world map. Think of it like your phone camera. When you zoom in close, that's large scale. You see tons of detail, but only a small area. Conversely, when you zoom out, that's small scale. You see a huge area, but lose the fine details. Just remember, understanding how maps work and how they don't work is crucial for everything we're going to study in AP Human Geography. You now know to ask, what type of map is this? What spatial patterns is it showing? What might it be distorting or leaving out? Maps aren't just helpful pictures. They're tools that shape how we understand our world. And now that you know their tricks, you're ready to use them like the geography expert you're becoming. Now go forth and question every map you see, because now you know they're all a little bit beautiful, probably pretty useful, and definitely somewhat dishonest. Thanks for watching.